Hi, my name is Rory Richardson, and I'm here to talk to you about how you can accelerate your business agility using serverless technology and microservice architectures. And I like to ground this in a little bit of context. So let's start where it all began. For us, it was 2001 on the Amazon.com side. See, back in 2001, like a lot of other enterprises and businesses, we had a monolithic application. And this application was called Obodos, and we had a Oracle database. It was in a master-slave configuration, but we just couldn't release code fast enough. Now remember, back in 2001, this is during the dot-com boom. So how can we get great code out faster? At the time, it was taking us about 11 hours of downtime in order to release new code, even if we wanted to just add a new product line. So we tried a lot of stuff, and not everything worked. But one idea that really stuck was an idea of moving to 2 pizza teams. See, 2 pizza teams is defining a group of individuals behind a service-oriented architecture, or what is effectively microservices today. I should clarify. Here in Seattle, we think a 2 pizza team is 4 to 6 individuals, because some areas of the world that ends up being 12 people, and other areas of the world that ends up being 2. So this idea really stuck because we were able to release code much, much faster by not having to release a major code change every time we wanted to update the application. And this is how we were basically decomposing the application into smaller bite-sized pieces. See, with 2 pizza teams, they're able to move a lot faster. They're more agile. They have more ownership. If they build it, they run it, and they own the code from cradle to grave. So this is how we now have 60 million deployments a year compared to roughly about 4 back in the day. Look, I could have told you it was 120 million deployments a year, and you probably would have believed me, because the difference between 4 and 60 million, well, it's just so astronomically different. But now we have thousands of teams and thousands of microservices. We've enabled continuous integration, continuous development, and we're leveraging serverless technologies in order to take all the heavy lifting off of our teams. But the second big paradigm shift is also the changes to compute. So back in the day, we all started with physical machines and maintaining servers. But when the cloud came around, we moved to virtualized machines. I still had people asking me, why would I trust a bookseller with my infrastructure as late as just 6 years ago? And for the folks that couldn't quite get used to virtualization, we used to joke, oh, those are the server huggers, because they really need to see the blinking lights. But then as we moved on, we developed containerization and isolation so that we could deploy code much, much faster. But at the end of the day, we were still maintaining servers. So we thought, what if we could even take that off of our 2 pizza teams, and we developed serverless technologies for compute, such as Lambda and Fargate. And this was really the missing link. The rest of the stack had already gone serverless, whether it was the notification systems or the database. And so the last piece was to get to serverless compute. Now let's talk about how folks other than Amazon.com are adopting serverless technologies today. So let's imagine the world as a 4x4 graph, because that's what Gartner taught us the world is. And we have legacy architectures that are monolithic applications, but folks really want to move to more modern architectures, leveraging microservices. And maybe they have a lot of stuff on-prem, but they really want to move it up into the cloud. So Nirvana, and I mean that in the Seattle way, not in the Buddhist way, is over there in the upper right quadrant. So the first step is you could take your existing architecture, you can put it on EC2, and great, you're up in the cloud. You're going to get efficiencies for scale and for cost and agility, and it's going to be great. But maybe you want to introduce a little bit more agility into your operations. And so you're going to use containerization like EKS or ECS or Fargate in order to get to that more microservice architecture. Great. Or maybe you have a different path and you want to box everything up into containers first, and then you want to shift it up into the cloud. Fantastic. But there's another type of customer who is skipping a bunch of these steps and is leapfrogging that adoption. And that's a customer like Fannie Mae. Fannie Mae had a legacy Monte Carlo application that they were running on-prem. And they thought, well, how far can we go with just one jump? And then they were able to leverage Lambda and to run that Monte Carlo simulation. And they got great efficiencies of not only cost, but also not maintaining that compute when they weren't using it. The next adoption pattern we see is by far the most popular. And what usually happens is we get folks started in IT automation type workloads like log processing or cron jobs. You're basically sprinkling a little bit of Lambda into an existing process. Nobody has to really ask for permission or go through a procurement cycle. Let's just put a little bit of Lambda in. Nobody will notice. And then they discover that's easy. And they start thinking, I wonder what else we could be using Lambda for. And so they quickly come around to thinking, well, what if we could incorporate Lambda into our event-driven architectures for data transformation? That usually takes on two different flavors, either linear or nonlinear. An example of a linear data ingestion would be where you have data coming in through Kinesis. You're doing some lightweight ETL with Lambda. It goes off to a data store like S3 or Dynamo, and then on to another Lambda operation, then to an end user. Kinesis to end user, that's a linear data transformation that's completely event-driven. So in other words, when you're not ingesting data, you're not paying for a bit of that infrastructure. So if you have a workload with high seasonality, especially if it's following maybe an agricultural cycle, well, your AWS bill will follow the seasons. The other example, it'd be something like nonlinear. A nonlinear data transformation is more like a data lake, where the main centers of gravity of how you're thinking about this infrastructure revolve around data islands. And those data islands are typically defined by the data temperature. In this case, you're using Lambda to move the data from place to place to get the insights that you need, or to transform the data out and back into an end user. This architecture diagram, just so you know, doesn't look like a 3-tier web architecture anymore. In fact, it looks pretty messy. You're not thinking about the servers as an area of gravity at all, because the servers are just responding to events within the data transformation. Then the last step that we see as far as adoption of Lambda is to use Lambda as the primary compute for a microservice architecture. Now, this is usually where we get executives involved, because now we're thinking about decomposing our teams into 2 pizza teams in order to achieve agility. This is where a lot of folks have publicly said, we have a serverless first strategy moving forward. And that's organizations like T-Mobile. This offers a lot of agility back into the organization, so they're going to be able to release more code more often. Some key considerations, like I said, are the organizational changes, but also what is our long-term commitment to this architecture? And then what are the effects for driving the business forward? The last pattern is the strangler pattern. And just so you know, that has nothing to do with strangling people and a lot to do with vines. There was a guy, Martin Fowler, who went on vacation to Southeast Asia, and he saw strangler vines growing on trees. Now, the thing with strangler vines is eventually the vines completely take over the biomass of the tree, and it's all vines and no tree. And this was the metaphor he was using to explain the migration from a monolithic application into microservice. And this is also exactly the pattern that Amazon.com took on when they began their migration from their monolithic application into a microservice architecture. Primarily, you're looking for events within the application and then applying an API. And then that becomes the definition of the microservice moving forward. This is not an overnight adoption pattern, but you piece away and chip away at the existing structure until it becomes all vines and no tree. But serverless is really more than compute. Remember I said compute was just the missing link. Did you know what our first service on AWS was? It was SQS. And the reason why is because we needed a way to communicate between all of those microservice teams. It is the neural system of a microservice architecture. But we didn't stop there, because when you think about more complex things that you want to do with compute, you're going to need orchestration, whether that means that you need to fan your Lambdas out and bring them back in, or perhaps you need to fire your Lambdas one after another sequentially. Or maybe you just want to pass state from one Lambda function to the other because you can't quite build the application entirely stateless. These things that enable a serverless architecture are the sort of the secret sauce or the glue that really makes serverless work. So this means changes to architectural patterns. So instead of this 3-tier web architecture, it gets to be a lot more complex because now the focus is on the APIs and not necessarily whether or not it has a layered architecture. Let me give you another example. Here at AWS, if we were all developers and we wanted to make a new application, what would be the first thing that we would do when we wanted to create a microservice? We would steal stuff, right? Because we're developers. I mean, that's what I would do as a developer. I would go to my GitHub repository or the internal repository and see if there's anything at all that already exists so I can just take that and modify it and get on with my job. But let's pretend we can't do that. Let's pretend we're actually going to have to create something new. Internally, we start with the API definition. And the API definition says, okay, these are the services that we're going to use for the application or the microservice. This is what it's going to achieve. Great. Then we submit that to our API bar raisers. Our API bar raisers are folks that are embedded in all the service teams. They've probably been with AWS a while, and they're going to evaluate our API on scalability and security. And if they give us the thumbs up, we are off to the races. But this is a way that we're creating our address book or phone book of where all of our APIs are so that they are reusable within our internal repository. So APIs are really the front door of your microservice architecture. So we talked about two pizza teams, but stuff did not get real in 2002. In 2002, we got a mandate from Bezos that said, "Thou shalt have hardened APIs." And he set out the definition of a hardened API with these 5 tenets. Basically, it was establishing that our internal APIs were going to be following the same standards as an API that we would make public. So the API definition and APIs became the structure of our two pizzas team's responsibilities, as well as a hardened front door and SLA of how that microservice was going to talk to all the other microservices. That means internally, every microservice is just a collection of doors. And how we define those doors with throttling and blue-green deployments helps determine our agility of how fast we're going to be releasing code behind that front door. So there's API-driven architectures, but let's not forget event-driven architectures, because there's tremendous cost savings by not necessarily evoking our compute until exactly when we need to. For instance, one key component of a serverless compute architecture is not letting the Lambda sit idle waiting for a response from something else. Instead, we can put it in a queuing service, and then the Lambda is fired back once we get a response from that other application or even a data store. So you see, messaging brokers are really the lifeblood of a microservice architecture and sort of the unsung heroes of what we're doing with AWS and Amazon.com today. But I just want to be super clear. The changes that we've talked about at the application tier in order to get to a microservice architecture were really easy compared to what it means to the database. All right, now I'm going to use a really funky metaphor, and I want you to just hang with me because it'll make sense in the end. Let's imagine your centralized database as the Death Star. Hang with me. It's because your Death Star is highly centralized, right? It gives you one version of the truth. You probably have configured it in a master-slave configuration. But if you've adopted a microservice architecture, we can imagine that as a squadron of TIE fighters, right? And they're all connected back into the centralized database. This is a perfectly okay microservice architecture diagram. But there's challenges to this diagram. For instance, how we're dealing with concurrency and connection pooling and contingency of the data. That can be really challenging when we're all trying to get back into the same source. And we all know what happened to the Death Star. Twice. So, let's think about this problem a little bit differently. I mean, after all, this actually happened to Amazon.com back in 2007. We had an Oracle database. It fell down. We couldn't get it back up. And Amazon.com went down for 3 days. So we had some challenges to our database strategy. And so we did a really interesting thing. We reimagined the database. How we reimagined the database is kind of interesting because if you think about how relational databases were built in the late 1970s, you have to think about what they were designed to do. They were designed to optimize for the most expensive piece of your infrastructure. And back then, what was the most expensive piece of our infrastructure? It was storage. Storage was incredibly expensive. And relational databases did a great job optimizing for it. Today, what's the cheapest piece of your infrastructure? Give you a hint, starts with an S. Storage. All right. So let's reimagine the database. Let's optimize for CPU instead of optimizing for storage. And that's exactly what we did. Werner Vogel, Swami Sivasubramanian, and a few other folks got together and they reimagined the database as a key value store. They published a white paper and that eventually became DynamoDB. Well, one of the key features of a non-relational database? No stored procedures. That means changes to your database and your business logic is more in the application tier and less in sort of a black box of your stored procedures. So this can offer a lot of agility to an organization. So let's imagine a different architecture diagram. Instead of a squadron of TIE fighters, let's imagine a squadron of X-Wings. Because what is the key technological advantage of a squadron of X-Wings compared to a squadron of TIE fighters? Come on, I know you know this. It's R2-D2. These guys have their database in the back seat. They're not coordinating with a centralized source. You take one of these guys out, what happens? Nothing. They just keep on fighting. Now, a decentralized database strategy can be scary at first because we all grew up with relational databases. But it does offer a lot of advantages, especially if you're not using stored procedures. Let me give you another example. When Amazon Fresh launched, it had an entirely different ordering system than we use on the retail site. Well, to most database folks, this could have been a disaster, but it also offered us a great deal of flexibility. So once Amazon.com had also moved on to non-relational databases, our ability to merge those two into a single customer experience wasn't that hard. Look, if you have organized the perfect relational database, that is the best database in the world. If you know all of the questions you will ever ask of your database, ever. The thing is, we don't. We need a more flexible way to be thinking about our data infrastructure and align it with what we're doing at the application tier. So each of the X-Wings is actually aligned behind a separate API. And when you think about resiliency, there's a challenge with one of the X-Wings. We have failover to maybe a previous version of what that microservice was to do, and the application keeps on humming. This also means that it's crucial changes to the delivery of the software. Because back in the day, we have to build, test, release, and monitor one major release that we may have once a quarter. But when we align everything behind an API, then we're able to build, test, release, and monitor all the time behind that protected API. So when we talked about two pizza teams, I put it originally in the context of 2001. And I said, wouldn't it be great if we combine developers and ops? Because you know what happens when you put a pager on a developer? You get great code because they have to deal with a lot of the challenges that you have later down. And this was great. But we've already talked about how we have changed the role of ops by moving to a serverless model. In other words, ops is no longer thinking, oh gosh, should this be on an M4 8XL, or maybe we should migrate to the M5 8XL because we're going to get better efficiency. Okay, so let's talk about what that means. So in a traditional application development, your developers are going to get really busy right up until launch. They're going to throw it over the fence on a Friday afternoon. Ops is going to catch it. Ops usually hates developers because they've given them something buggy that they can't optimize, they can't scale out. But then we had that idea of DevOps and it was combined and the world was a better place. Hallelujah, fantastic. But they're still maintaining servers. So how do we get more out of a finite resource? Remember, we're not increasing the size because it's still 4 to 6 folks. Well, with a serverless architecture, a lot of the problems that you have in operations have to be solved on the developer side. So even though it may be a little bit more thinking on how you're organizing with serverless architecture, your scale out on operations will probably be less. There'll be less cost optimization to do as well, because you're not going to be able to optimize your CPU after the fact. I recently interviewed some of our largest enterprise customers, and I asked them, okay, in your data center today, what do you think your CPU utilization is? Nobody answered over 10%. That means 90% of the CPU in the data center was underutilized. So what if we only pay for the CPU we're actually using? Some of these concepts may sound familiar if you're really old. If you have ever had to play around with COBOL, when you are coding for a mainframe, you know that you have to allocate the vCPU at the function level. You only have one box, so the only way that you can manage your resource allocation within your infrastructure is with code, because you're writing infrastructure as code. I hope this sounds familiar because it's basically Lambda. What is old is new again. Now, if you think about how mainframes were organized and how important the messaging broker was, then you understand event-driven architectures. So if you think about it, we're just your mainframe in the cloud now. So the reason why our customers are moving this direction is to reduce the undifferentiated heavy lifting, create business agility, and really optimize the cost by paying for the things that they're actually using. And it's not just Amazon.com that's going down this path. A lot of other organizations are organizing around this modern digital business. We're starting with the customer and working backwards. They're organized for value. I mean, if you could get your stack organized so that you know how much your infrastructure costs per API request, that means the cost of your organization would directly be following the money coming into the organization. They're all technologists at core. It's no longer something they can throw over the fence to another area of the business. And they're making strategic use of their data instead of leaving it siloed within different parts of the organization by opening up to APIs. And it's not just us. It's Capital One, Guardian, McDonald's, FINRA. And I've already mentioned a few others that are going down this path rather aggressively to introduce agility back into the organization. You may be thinking to yourself, oh, I don't know how I'm going to get to there from here. I mean, my developers are used to centralized databases. They are very much used to their pipeline organized around a set delivery schedule. We're here to help you, whether you're starting where that you were cloud native or whether you're an enterprise that are still in on-premise data centers. It's about where you are today and where you want to go on your journey and where you want to be in the next 3 to 5 years. And then how can we reduce the amount of tech debt that you're creating with your organization in order to create the most amount of value for innovation. So we're witnessing these paradigm shifts in a rather dramatic way, not only for microservice or service-oriented architectures, but also in how we're managing the heavy lifting in the underlying infrastructure. Because at the end of the day, we all just want to win more customers by building better products, innovating more often. That means we're going to be releasing code faster, focus on the business logic, and that means we got to decouple our software systems for agility. So thank you very much for taking the time to listen how you can create business agility within your organization. And don't just take my word for it. Take a look at our website on Serverless, where you can see white papers from IDC to Deloitte on the TCO of serverless in order to understand how these changes could affect your organization. We look forward to hearing from you and helping you on this journey.